Okay, so today we shall be talking about bonding and structure. That is our topic today. In bonding and structure, we'll just be looking at what it's meant by the term bonding and some of the types of bonding. We shall look at those two and other examples. So when you're looking at bonding, it's just a chemical combination of atoms or elements to form compounds. The force of attraction holding atoms or elements together in a molecule or a crystal is referred to as a chemical bond. So when two or more atoms join together, we call that bonding. The force that they join with, we call that a chemical bond. Okay. Below are some of the types of bonding. We have an ionic bond. Sometimes we call it electrovalent bonding. This involves the transfer of electrons from a metal atom to a non-metal atom. It occurs between metals and non-metals. Here is a structure showing an example of an ionic bond. We have a metal here that loses electrons to another atom, which is a non-metal. So here what is involved is loss and gain. A metal atom loses electrons, like the way this one is losing. Okay. And then a non-metal gains those electrons. That is an ionic bond. We also have an electrovalent bond or electrovalent bonding. This one involves sharing of electrons between two or more non-metal atoms or elements. The atoms or elements involved contribute to the bonding electrons. We're going to look at each of these in detail, so here I'll just go through them briefly. So in covalent bonding, it is all about sharing. Everyone is sharing the outermost electrons that they have in order to make a bond. Here is an example of a covalent bond. The electrons that are shared are here. These two electrons are the ones that are being shared. Each of the atoms introduced one or brought in one electron, and they shared them right here. This is where the bond is formed. So these two electrons make up the covalent bond between these two atoms. Okay, that is covalent bonding. Okay, so that's the covalent bonding. A very good example is here of covalent bonding. These three guys are covalently bonding on this stick, which acts as a bond amongst the three of them. Right? It's a very, very good example of what a covalent bond is composed of. It's all about sharing. Okay? If you're not sharing, you're not covalently bonding. Another example of bonding is dative or coordinate bonding. We call it dative or coordinate bonding. This one involves sharing of the bonding electrons, which are donated by one molecule or atom. Now, this one is mostly confused with covalent. You might confuse it with covalent bonding, but they're not similar. We saw that in covalent bonding, each atom brings an electron to be shared. Here, it is only one atom that introduces the electrons to be shared. So in dative bonding, the electrons come from one atom. That's the difference. A very good illustration is here of a dative bond. In a coordinate bond, also called a dative bond, it's a covalent bond, but here, because since electrons are shared, we can call it a covalent bond, but here, both electrons come from the same atom. And that's the key, that the electrons come from the same atom. In covalent bonding, it doesn't come from the same atom. But we like to say it's a form of covalent bond because there is sharing. Every time you see sharing, just know you're dealing with something related to covalent bonding. The difference is here in a coordinate bond, electrons come from the same atom. That is the difference. Let's look at this diagrammatic representation and try to understand where this is coming from. Here we have ammonia reacting with some hydrogen ions to form ammonium ions. Okay. Now, we see that the rest of the hydrogens are well bonded already to the nitrogen in the ammonia. But we have this hydrogen ion that wants to join the party of ammonia here. So what it does, the hydrogen, the nitrogen here, it has this lone pair of electrons. That pair of electrons, we call it a lone pair because there are two electrons and they are not bonded to any atom on the nitrogen. That's why we call it a lone pair. This nitrogen is going to introduce these electrons to this guy here so that he can join in on the party, the hydrogen ions, so that they can join in on the party that is taking place on the ammonia. And here it is represented. The two electrons attract, the lone pair attract the hydrogen ions, okay? And now it is bonded very well here, right? That is the dative bond, okay? Nitrogen introduced the two electrons to this guy, so he was attracted and he joined the party to form the ammonium ions, okay? So that is the dative bond. Do not confuse it with the covalent bond because we have seen now the difference. Here, all the electrons that are shared are introduced by one atom. Here they were introduced by the nitrogen atom, which attracted the hydrogen ions to form this. So the bond here formed with these two electrons is what we call the dative bond, okay? And it's right there. So this is a very good explanation or illustration of what we mean when we say a dative bond or coordinate bond. That's it right there. Okay. Can continue. Please, if you have questions, you can always type them in the chat. I'll look at them. Type them in the chat if you have any questions or concerns or something you have not understood. So far, that is the dative bond. We have looked at the covalent also and the electrovalent. Okay. Now we have the metallic bond. The metallic bond is a bond that occurs between atoms of metal elements. There is a word metal in the word metallic bonding, meaning it occurs in metals. Nowhere else but in metals. Okay. We're going to see how that occurs. So in metallic bonding, here is an illustration. We see that it occurs in metals. Metals consist of positive ions. Metals consist of positive ions, which are surrounded by Sc. Sc, by Sc we mean so many of mobile electrons. Sc of mobile electrons. Okay, so this is the makeup of metals. We have positive ions surrounded by a sea of mobile electrons. By a sea, we mean so many mobile electrons. Okay. Now here, this diagrammatic representation shows us what we mean. This shows what a metallic bond might look like. We see the positive ions surrounded by these electrons. Surrounded by these electrons. Okay. And that is the makeup of metals. And that shows how the metallic bond works. Okay. Positive ions surrounded by a sea of electrons. Here are some of the characteristics of a metallic bond. They are very, very good conductors of electricity and heat. And the reason for that is because of the free mobile electrons. These electrons can move in the metal everywhere. Okay. They keep moving, therefore they can transmit the heat, the electricity, and whatever. Okay, if they were static, they would not, it wouldn't be able to conduct electricity, but since they can move around in the metal, that's why they can conduct the electricity. And that shows how the metallic bond works. They have great strength, they are malleable and ductile, and then they are luster. Okay. So that's the metallic bond right there. And here is this angry guy asking himself, metallic bonds, why you know bond with something other than metals? He's asking himself, why? Why do you only bond with only metals? What is going on with you guys, the metals? So the metallic bond, again, it occurs in only metals. Here is a simple summary of these bonds before we look at the main one of today. We have the covalent bond. We can see how happy covalent bonds are because the sharing involved. We have the metallic bond where we have positive ions surrounded by a sea of electrons. We have an ionic bond where one gives, okay, and the other receives. And then we have a coordinate bond where one donates electrons for sharing. So those are the bonds that we are looking at. Like I said, we shall look at each in detail. For now, we'll go just on a shallow on each of them. Okay, now the first one we shall look at in detail is the ionic bond or electrovalent bond, electrovalent bonding and ionic bonding. Like we said, this involves the transfer of electrons from a metal to a non-metal. The number of electrons lost by a metal atom or gained by a non-metal atom is equivalent to its valence. So that is something important to remember, that the electrons gained or lost is always equivalent to the valence of that particular element. The loss of electrons from a metal atom leads to the formation of a positively charged ion. When you lose electrons, you become more positive. Therefore, in this type of bonding, the metal that loses electrons becomes a positively charged ion, which we call a cation. And the gain of electrons by non-metal atom leads to the formation of a negatively charged ion, which we call an ion. An ion. The positively charged ion and the negatively charged ion are attracted to each other. So these ones, like you've always had, unlike poles, attract each other. Here, the positively charged ion and the negative charged ion attract each other to force, and the force of attraction holding them together is known as the electrovalent or ionic bond. So that attraction energy brings about the bond to be formed. The compounds formed are referred to as ionic compounds or electrovalent compounds. We shall look at examples. And atoms lose electrons, so right, to have a stable configuration of noble gases or non-metal atoms also gain electrons to become stable. So the whole reason why this bond occurs is because elements or atoms have that need of being stable. When a metal loses its outermost electrons, it gains a noble gas configuration. Its configuration becomes sort of like those of the noble gases, meaning it's becoming stable. Non-metals the same. Once they gain, their outermost shell is filled, therefore gaining that type of configuration of a noble gas. So that's the reason why electrovalent or ionic bonding occurs. Atoms have the need to be stable, so they either lose or gain electrons. Okay. Please, if you have questions, type them in the chat. Remember that. A covalent bond yields at an ionic bond. Did anybody ever teach you to share? See, covalent bonds are always very, they judge ionic bonds seriously. Because for them, they are used to sharing, yet ionic bonds, there is no sharing bond. So this covalent bond was yelling at the ionic bond, hey, did anybody teach you how to share? I guess the ionic bond will also yell at the covalent bond, hey, can't you lose or gain? Why do you want to share all the time? That type of scenario. Can only imagine. This is a very smart cat. All right, let's continue. Formation of some ionic compounds. So this is, we're going to almost the last part, and I'll give you an activity about this. So formation of some ionic compounds. Our example that we shall use today is sodium chloride. Okay. When sodium chloride burns in chlorine, when sodium burns in chlorine to form sodium chloride, the sodium atom loses an electron and forms a positively charged sodium ion. Okay, like we have seen. While the chlorine atom gains the electron and forms a negatively charged chloride ion, which is right there. Okay, so that's what happens during the bonding that occurs between sodium and chlorine to form sodium chloride. Sodium chloride, I believe every one of you have seen sodium chloride. If you know what it is, you can type it in the chat. What is the common name for sodium chloride? Type it in the chat. I want to see it. Someone has already typed it. See. Kusima said table salt. Kusima, that is 100% correct. Well done. So sodium chloride is table salt. It's the normal salt you use at home. And that is good to know. Let me see, someone else typed it. Common salt, Peter said common salt, that is 100% correct. Well done. Yeah. So that is ionic bonding, and that's a very good example of how ionic bonding occurs. Let's see the diagrammatic representation of this. So here is the diagram. We have the sodium atom. This is its electronic configuration. It is 2 to 8 to 1, meaning it has one electron in its outermost shell, okay, which is right here. This is the electron it has in its outermost shell. During the ionic bonding, it is going to lose this electron to chlorine. We see that chlorine, its electronic configuration is right here. Chlorine has 7 electrons in its outermost shell. So it's going to need an addition of 1, to become stable. Okay, an addition of 1 to become stable. And this one is going to come from sodium. Okay, it's going to come from sodium because sodium needs to lose 1 to become stable, to have a full shell here. Okay, also when chlorine gains 1, this 7 will instead become an 8. Okay, that's how it works. So this is what we are seeing here. The 1 electron that is on the outermost shell of sodium is lost to chlorine. Chlorine gains it right here. Okay. As a result, this loss and gain here, we are going to form a bond, which we call the ionic bond. The final structure will look like this. Okay, this is the final structure to look like that. We see that now sodium has a full a noble gas-like structure, meaning the outermost shell is full, has 8 electrons, and you can count them here in the outermost shell. Okay, they are 8. All right. Also, chlorine, since it has gained, we see that it has now a full outermost shell, gaining a noble-like structure or a noble gas-like configuration. And when you count the electrons in this outermost shell, they are 8. So this is the resultant structure. In between them, a bond has been formed, which we call the ionic bond. So that's how ionic bonding occurs. If you have questions, please don't forget to type them in the chat box so we can go over them. So that's ionic bonding. I'll pause a little bit for you to ask questions. You have a minute to type a question about ionic bonding or any other thing we have covered in the chat box. And then we can look at it. Okay, we can continue. So here is an activity for you guys, a very nice activity that I want you to do. Okay, I'm going to give you time to do it in the group before you go for your next class. So here is the activity. Illustrate the formation of the following ionic compounds. Just like we have seen previously, I want you to do this type of thing, okay? This type of thing for each, this type of illustration for each of the following compounds. The first compound we have is potassium oxide. The second one is calcium oxide and magnesium chloride. I want you to do the same illustration like we have seen previously with sodium chloride for each of these. This is how I want you to do it. Do it on a piece of paper, okay? Take pictures and post in the WhatsApp group. That is the activity for today, which I want you to do. Thank you for attending. I hope this lesson was good for you and you've learned something. Again, we have videos and very many activities and interacting content on our website. You can always visit and go through them. The links are here. I'm sending these notes in the group for you to use. I want to see that work in the group that I've given you. Yeah. Let's move on. And someone has typed something. Oh, thank you, sir. Oh, you're welcome. Do the activity. I want to see it. I want to see the activity in the WhatsApp group. Thank you very much for attending. Let's go on and do the activity before we go for our next class. We have about 15 minutes to do the activity. So use this time very well. All right, well done. Someone typed something. Let's see. Oh, yeah, I believe we are making tremendous progress. Yeah, thank you very much. All right, please go on and do the activity. Jackie, you had something to say? Please type it in the chat before we leave. Jackie, if you have something to say, type it in the chat. Or you can type it in the WhatsApp group and I'll make sure to answer it. Well done. All right, let's see the activities in the WhatsApp group. You have 15 minutes to do the activities.